So V equals I times R equals 10 times 10 to the minus 3 amps times 500. Yeah, that'll be 5 volts. You do. Micro, nano, any of those, you have to convert it to straight up amps.
What's the F symbol for again? Not in this, like.
What's the what symbol?
F.
F symbol?
Yeah.
You're great. Laugh at him, YouTube, laugh. The F symbol stands for farads.
Everybody in this room knows that's not correct. Everybody
F
in this room is happy in their class.
is for farads.
Yeah, that's true.
Yeah.
Farads. So what about if we have microfarads? We convert those.
Convert that into just plain farads. Anytime you have a prefix in front of one of these variables, micro, milli, nano, any of those, killi, any of those, well, not kilo, that you don't convert, kilograms. But you almost always convert it into just plain farads or volts, because those are the SI units.
And those are in that sheet you gave us?
Yeah, those conversion factors.
Oh, okay. Because I lost that sheet.
Haven't emailed me to remind me to.
It's fair.
I will never remember to do anything unless I have it in my email.
Email me to remind me to email you.
Not gonna happen. Okay. Next question that was asked about. Problem number 15. So looking at problem 15, I think the tricky part of this problem, it says using the results of example 20.3, find the drift velocity in a copper wire of twice the diameter and carrying 20 amps. So you literally have to go to example 20.3 and look at it, and you just do the exact same thing that 23.3 does. You just change the diameter. So instead of your diameter being, what is it? I think instead of your diameter, as they gave you in example 20.3, was 2.053 times 10 to the minus 3 meters. That's what it is originally given. They now want you to assume that the wire that you're having this current travel through is twice as big, so your diameter is double that. So that's 2 times 2.053 times 10 to the minus 3 meters. So that's your new diameter, which means you have a new radius. Because as you're solving this problem, as they show you in example 20.3, you need to find the area of this wire, the cross-sectional area, which is pi times r squared. So that's pi times r, which would be the diameter, which is 2 times 2.053 times 10 to the negative 3. Divide that by 2. Diameter over 2 gets you the radius, right? So the 2's go away. Square that. You get your new area. Your new area is 1.32 times 10. I believe that's a negative 5 meters squared. And then you can calculate the drift velocity, VD. We're kind of like PT health students, so VD stands for drift velocity in physics, not venereal disease. Okay, so VD is I divided by N times Q times A, and all these other variables are given to you in example 20.3. So if you read that example, you will find all of these numbers. So you plug in all your numbers and just get negative 6.45 times 10 to the negative 4 meters per second. So the tricky part of that was going back and just reading example 20.3, and it walks you through. Yeah. You'd either be given it or you'd be told how to actually calculate it. Any other questions?
What is that stand for?
Electron density inside of a wire. So that changes depending on what kind of wire you're using. It's pretty good for copper. That's why we have our wires made out of copper inside of our walls. Actually, something I learned at a trivia night, like last Sunday. Copper wires conduct electricity very well, but they're not the best conductor. So that was my guess. The question was, what is the best conductor of electricity? I said copper, because that's what wires are made out of. They have a high electron density. The highest is actually silver. So silver has a very high electron density. Why don't we make our wires out of silver? Because it's more expensive. Copper's cheap.
So would Ed be given to us or
It would either be given, or I would tell you how to calculate it. I would give you the equation to calculate. Okay. Any questions on these two? 8 or 15? No? Okay.